Hello, everyone. Welcome back. We are now on our last step of understanding titrations. This is putting it all together, part two, or otherwise known as using titrations to make conclusions. So, to remind you of what we are working with, we are working with a titration of sodium acetate plus hydrochloric acid, and this reacts to form NaCl plus acetic acid. And at this point, we have walked through how to calculate the pH at various points along the titration curve. We've talked about how to interpret the titration curve and the things that are in solution at the different points. We've also talked about how to find the equivalence point if you have titration data. And now we're going to talk about how we can use that equivalence point that we found experimentally to make conclusions about our solutions. This is what you are going to have to do in your titration activity for CH231 lab. Okay, so let's get going. So this is our titration curve. Remember, we talked about how the pH, this is of the solution, and the volume of HCl added is what is from our burette. And so in our case, we have our burette that contains HCl, and we have our flask that contains our sodium acetate. And in the last example, in the last video, we found the equivalence point, and we found that the equivalence point occurred at the point 13.67 milliliters with a pH of 7.058. Okay, so we are going to use this information to learn things about our sodium acetate solution that we were titrating. Okay, so one thing that we can find from titration data is the concentration of our solution. And so this question asks, what is the concentration of the 10 milliliters of acetate that was used in the titration if the equivalence occurred with the addition of 13.67 milliliters of 0.3 molar HCl? So let's draw ourselves a picture just to make sure that we know what we're doing. We have our burette with 0.300 molar HCl, and we added 13.67 milliliters of the HCl into our flask, and our flask contained 10.00 milliliters of sodium acetate, or we know that that sodium ion doesn't do anything, and so we can think of this as just the acetate. Okay, so, and we want to know what is the concentration of this 10 milliliters of solution. Okay, so to do this, the first thing that we need to do is the first thing we do in a lot of our problems. We first need to find the moles. And it turns out that we have enough information about our HCl to be able to find our moles of HCl. And so we have 13.67 milliliters of HCl. I'm going to convert that to liters. And then I'm going to use the concentration to find moles, and I get that there are 4.101 times 10 to the minus 3 moles of HCl. Now, we're doing a titration, and so the second step is that we have to do stoichiometry. Titrations are reactions. For all reactions, we have to do stoichiometry. And so the reaction we are working with is HCl plus, I will do this as sodium acetate, plus our sodium acetate goes to form NaCl plus our acetic acid. And so we have 4.101 times 10 to the minus 3 moles of HCl. I can use the balanced chemical reaction to know that there's 1 mole of HCl reacting with 1 mole of our sodium acetate. And so we get 4.101 times 10 to the minus 3 moles of sodium acetate. And so now step 3, we can find the concentration. And so molarity is equal to moles divided by liters. And so I have 4.101 times 10 to the minus 3 moles. And that's how many moles were in this 10 milliliters. So convert that 10 milliliters to liters, and I get that my concentration is 0.4101 molar. Okay, so the other thing that we can do with titration data, and this isn't the only other thing, but the other thing that we are going to do with our titration data in the lab assignment is to find the Ka of our unknown. And in this case, it's not an unknown. In this case, I'm telling you that it is sodium acetate. And so we could go to the Ka table and look it up. But in the problem that you are doing in lab, you don't know what the base is. And so we want to figure out, I'm going to do this example of what is the Ka of the 10 milliliters of acetate used in the titration if the equivalence point occurred with the addition of 13.67 milliliters of 0.3 molar HCl. So we are going to use the fact that the pH is equal to the pKa at what is known as the half equivalence point. And I am going to work through this example to prove this. And then I will talk about how we actually answer the question. Okay, so at the half equivalence point, the half equivalence point for this example is equal to half of the volume that it takes to reach the equivalence point. And so that is 6.835 milliliters of HCl. So, and we also know from the previous problem that our concentration of acetate is equal to 0.4101 molar. Okay, so to do these problems, the first thing that we have to do is we have to find out what is in solution. So we have HCl plus our sodium acetate. I'm sorry guys, I'm not being super consistent. Sometimes I leave the sodium on, sometimes I take it off. I hope that by now you are comfortable that sodium is just observing things and is not participating in the reaction. Okay, so what is in solution? To do this, we have to do stoichiometry, which means we have to use moles. And we know that moles are equal to molarity times the volume. And so at the half equivalence point, I find that I have added 2.051 times 10 to the minus 3 moles of HCl. I have 4.101 times 10 to the minus 3 moles of sodium acetate. I don't care about my NaCl, and I start with no acetic acid. Since this is all 1-to-1, we know that the HCl is the limiting reagent, and so there's now no HCl left, and I get 2.051 times 10 to the minus 3 moles of acetate left over, and that makes 2051 times 10 to the minus 3 moles of acetic acid. And so now we would find the pH. What we have going on is a buffer. So we can find the pH using the Henderson-Hasselbalch. Whoops, not Kb, pKa plus the log of the concentration of the acetate divided by the concentration of the acetic acid. And to find these concentrations, I'm going to take the moles, 2.051 times 10 to the minus 3, divided by the total volume. And so that is 16.835 milliliters, or 0.16835 liters, which is equal to, I did this problem wrong on my notes, so I gotta type it into my calculator, is equal to 0.122 molar. And it turns out, if you notice, that the moles are the same, and so the concentrations for both of these are going to be the same. And so pH is going to be equal to the pKa plus the log of 0.122 molar divided by 0.122 molar, or the pH is equal to the pKa plus the log of 1. Now, it turns out that if you type this in your calculator, you will find that the log of 1 is equal to 0. And so this means that at the half equivalence point, the pH is equal to the pKa. So how do we find the pKa? Well, we have our titration curve looking something like this. And what we have to do is we have to use our titration curve. We have to find the half equivalence point on the titration curve. And we use that and we read the pH off of the graph. And so we want to find, using our data, the pH at the half equivalence point. And we will then be able to know what the pKa is. Now, let's make sure that we understand our algebra for the next step. And so from the pKa, we need to find the Ka. And remember that pKa is equal to minus log of the Ka. And so that means to undo this, we use our log rules, and the Ka is going to be equal to 10 raised to the power of the negative pKa. And so you use your graph to find the pKa, and then you use algebra to find the Ka. Okay, so that's all I have about titration. So the next unit of videos are going to be a little more about buffers, and buffers are going to be your second assignment for CH231. So with the end of this video, you now have all of the information that you should need to be able to do the the titration assignment for CH231, which is your first assignment. So if you've got questions, feel free to reach out, post on the discussion board, come to office hours. I will be doing a pre-lab lecture next week, which is the week of March 23rd. And in those, I'm going to walk through and summarize what I've covered in detail in these videos. So those pre-lab lectures are optional. Come if you would like. And I hope you are learning to adapt to this new style of learning, and let me know how I can help. Thank you.